Alright, what's up, guys? Um, so I'm gonna be showing off this game engine I've been working on for a little bit. Um, it's all custom written in C++. A very minimal featured C style flavor of C++. Um, it's a recreation of the original Legend of Zelda for the NES. I made that just because I thought it would be simple and good for practicing writing game engines and stuff like that. I don't have to worry about game design and stuff when I'm writing a game that already exists. Um, yeah, I'd work. There was a period where I was working on this every morning for an hour and a half, a couple hours, just trying to implement whatever features seemed important at the time. So it's not gonna. I didn't develop it as trying to exactly replicate sections of the game. So you could see parts of the map are the same, but really I was going for trying to get the most out of each hour that I worked with. So just trying to get as many core features and stuff like that in the game as I could, rather than trying to just make things one to one with the game from the get go. Um, yeah. Also, a lot of this was made after I followed the Handmade Hero series by Casey. So that's kind of where I got the framework for building this stuff with the platform code, the Win32 APIs and the game controller APIs and stuff like that. Um, and then I kind of just deleted a lot of the stuff that was for his game, and then I just kind of did my own thing using what I learned from that. So yeah, I mean, you could see we got some enemies running around here shooting stuff. Um, I have sprites drawn, like a tile map, and then you see we got some collision boxes around Link. These are little debug icons I have right now. Um, yeah, I could run around. I could run into this guy and take some damage. Um, yeah, I have a boomerang. I have a bomb. Um, I have a sword I could go get. So I go into this cave, and then I get bro up in here, and then I take the sword. So yeah, now that I grabbed it, it's in my inventory, and now I could, bro, where is it? Now I use the sword, and it's a slow animation. Um, yeah, we got animations going up in here, so Link kind of he walks. We got text drawing. Um, yeah, you can see when I walk in here, the text scrolls, so that's pretty cool. Here, let me make this a little bigger. Um, yeah, so I could attack enemies too. So when I use the sword on them, they take damage and then they flicker, and they all have their own HP. And I could throw a bomb down, and then that will explode people. Yeah, I'll go over here, and then this is the dungeon area. So yeah, I mean, again, obviously this is not the actual Zelda map, but I was okay, I got a couple overworld stuff in here, and now I want to do a dungeon stuff because that just kind of sounds interesting to work on. So yeah, in the dungeon, we have this locked door that you can't get into. We have a push block here, so I could push this guy around, and I have to hold him, and gives it a feel, so that you're "Ugh." And then yeah, you pick up the key, and then it does the what? And then I use the key, and I unlock this door. Yeah, I have to kill this guy. Come on, get out of here. Yeah, so I kill this guy, and then it opens the door down here. Yeah, so I mean, I'm just showing off as many features as I can right now, just to give you an idea of what's going on. Yeah, there's this guy. Poor guy's stuck in here. Take him out. Boom, boom, boom. Yeah, so that's the engine. Oh yeah, and so this whole thing is all rendered on a 256 by 320. I don't. What even is the resolution, dude? I don't remember. But it's it renders at a small resolution, And then I just like scale up that image into a Windows 32 window and then just display it there. And it's all using like software rendering, so no need for like OpenGL and stuff like that, because it's such a small like buffer that it's like it's really cheap to draw this stuff. So yeah, I mean, let's close that out, and then I can pull up some code here. Yeah, so just to give you an idea of the architecture, I could start on the platform side of things. So yeah, I mean, we just have this massive platform layer, 1,500 lines of code. That's all basically one file. If you've done Handmade Hero before, this is gonna look like really familiar to you. Um, so like, yeah, you could see up top here, we only use a couple libraries. So we use the Xinput library, and like it's all we load all these functions like dynamically. Um, yeah, we have some direct sound stuff. Um, and then yeah, we just use like Windows 32 APIs straight up. So yeah, there's no like no Raylib, no like there's SDL stuff like that. I was just like interested in making my own platform layer for this. I just kind of thought it was cool. Um, so this is the platform layer, and then the game is written so that you could load it as just like a single update function, which you just kind of give it a game state, and then it will update based on like the time delta that you give it, and then it will like return an image buffer that you could display onto the window. So yeah, I mean, I load the game as a DLL, and there's two functions. There's like the update and render, and then there's like the get sound frames. I'm not doing sound right now for this game. I'm just doing the update and render. But yeah, you can see my platform layer. Like I just have this video buffer, and then I pass this buffer along with like some memory that I allocate, and it's all just like a massive memory arena that's like 4 gigabytes. That's all memory for the game. And then the platform layer handles like the inputs and stuff like that, and it just passes it all into this game update and render function. And then yeah, so like you could expect to get the video buffer populated by the game, and then like later down the line we just oh yeah, this is backed by this global back buffer. So then what we do is we just kind of like stretch DI bits this display buffer out onto the screen. So like we do some math to kind of stretch it out. So yeah, you can see I like multiply it by the ratio between how small the image is, and then we have to like stretch it so that it's like larger amount of pixels on your screen. But yeah, that's kind of the gist of this platform layer code. Like, and then yeah, over here you can see we got all this input handling stuff if you have a controller. I'm mostly just testing this thing on mouse and keyboard. Oh, and then yeah, one more thing to note is like, so the reason that we load the game as a DLL instead of just like statically compile everything together is because it's basically just hot reloading. So when I'm developing the game, like I might have it up and then I want to like, change the position or like a color of an enemy sprite or something like that. Instead of having to like, test the game and then like make my edit and then recompile the thing, close the game, and like open it back up and then test the changes, I could just kind of like, make my changes but keep the game running and then recompile the game as a DLL. So then what happens is the platform layer will see that the DLL timestamp is like newer than the old one, and it will just like load that one in and say like, okay, let's use this DLL instead, and now it's using the latest update and render function. So if I make any changes, I could just press recompile, and then like it instantly just appears on the screen in a second. Pretty sweet, dude. Yeah, so over to the game code. here, let's start in the .h file just to talk about like the architecture of this game, dude. So yeah, I mean, we have some basic type stuff, like, you know, you do the classic, like declaring all of your types, uintate, all this. But the interesting thing is, oh yeah, so the platform also has a couple services that it gives to the game layer. So we have like some file read and file write stuff that's used. But the main architecture of the game is that you just pass it, like it's memory arena. So that's just the game's RAM that it's going to use for, you know, the whole runtime. And then you have this massive game state struct. Yeah, that's right here. So this game state struct, it just contains like, it's just this massive struct that I just, when I don't know where to put something, I just kind of dump it in here. Which seems a little odd, but like it actually works out pretty well, and like once you get the hang of it, it becomes like really nice to program with just like a giant game state. Because whenever I want to add a new feature and I'm not sure how I'm gonna do it, I'm like, how do I, you know, implement a boomerang? I could just kind of like, I don't have to think about some like perfect entity system or something like that. I could just be like, okay, well, you know, I'll add in my boomerang direction and my boomerang position and player using boomerang, and like I'm just gonna get something working with that. And then once I have something that I'm happy with, or something that works, then I could like refactor it from there. But yeah, this whole game state thing, it makes it really easy to get something just kind of working, just so you could test out your ideas really fast. Yeah, so this game state, you know, it has stuff about player position and like lots of gameplay stuff. And then also we have a lot of stuff, like all the textures that we load for the game, we just kind of dump them in here. Yeah, and then we have some entities. Do I put that in here? Let's see. Oh no, entities are not in here. So yeah, the game state is a pretty central thing to the architecture. And then another thing to mention is the entity system. So all of the mobs and NPCs and, you know, the items like your bomb, and then, you know, the boomerang and the sword that you pick up off the ground and the key and the fire and the push block, like all that, you can see we have entity types for each of these. And then the actual entity system, like everything is all the same entity struct. So we just have kind of the same way we had the game state giant struct, we just have the single entity struct. And any property that could possibly go on an entity, it's just all freaking in here, dude. We just don't care. Which, I mean, so I've never programmed an ECS myself, but I think this is kind of like the idea of an ECS. But like instead of making it like more modular, I just kind of dump it all on the same struct, because, you know, it's using such a small amount of memory in the first place. I'm like, why not? Let's just make one giant entity struct. So yeah, I mean, like when you register this stuff, like basically I could show you where these things exist. These are all inside our tile rooms. So here, let me boot up the game again. So each screen that you see in the game, this is all stored in the engine as just like a room. And then like each room has its collection of tiles, and it also has, you know, doors that go like to the right, up, down, and then doors like this cave over here. And then it also has a collection of entities in each room. So yeah, like if I go back to the code, you could see, oh, that's the wrong one. Yeah, so back in the code, you can see I have um, I just have an array of entities, and I could hold 256 entities in each room, which that's plenty. Um, and when I so you could just kind of, when you want to allocate an entity, what you do is there's some kind of function. Yeah, it's just allocate new entity in room. And this basically will just take, like, you take that entity array and you just say, give me a new entity. And this just kind of like goes through that whole entity array, and it will just find anything that's like not active, and then it will just return it to you. So, I mean, it's pretty fast because there's only 256 things anyway, and you're not like allocating these things all the time, so it works out pretty well right now. So yeah, you allocate an entity, and then for whatever type that you want to do, those might have certain defaults that are not the same as like the 0 values. So yeah, like for Octoroks and Moblins, I have like, this is how much damage that they do if you run into them. This is how they fire, like 60, every 60 frames. Yeah, so every second, because this game runs at 60 frames per second. Yeah, and they have 3 health. Fire, it damages you if you walk into it. The sword, it's not the default that you get, the default width and height. So I like, it's a little skinnier, so I have it like that. Yeah, so this is kind of how I handle defaults if the default is not going to be 0 initialized. Yeah, so like, I don't have any kind of map editor right now. Like, I find it pretty easy to just kind of allocate this stuff, to initialize this stuff all in one big block. Yeah, so I mean, I guess this is, I'm thinking about like big systems to talk about, and then we could start getting into like how this code actually works. Yeah, I think that game state struct, that's a pretty big central part. And then yeah, the rooms, like basically we have like a map, and the map stores a bunch of rooms, that all like connect with each other in certain ways. So that's kind of how I handle the whole like overworld and connecting everything together. Yeah, and then the entity system, that's like the last pretty large piece. And then everything else we could just kind of like run through this update and render function. I could kind of give you an idea of what's happening. Yeah, so like the first time you start up the game, we just kind of check if the memory is initialized, and like, so it's not going to be initialized, so that means like we do all of our initialization in this one big if statement. So yeah, like we initialize the arena. That's just like, you know, setting this basic stuff like, okay, how big is the thing, like where is this arena gonna start in our memory and stuff like that, just like all the pointers. Yeah, we just initialize all the player values, and then here we load all the BMPs. Yeah, this bitmap loader, this doesn't use any kind of library. This just kind of reads the file directly, and then loads it into a buffer for you. Yeah, and then we have this, like, the stuff to load tile sets. So yeah, here's a good time to show the sprite.h. So all of my sprites, everything just kind of has its own struct. So yeah, you can see like link sprites. It's just a bunch of these BMP tiles and BMP file stuff. Cause yeah, if I pull up the game data, you could see what I'm actually loading. What folder is it? I think it's this one. I could also look at the path here. Yeah, tiles link.bmp. So yeah, like the link.bmp. Um, yeah, let's open photos. This is just kind of like this giant tile set that I ripped from the internet. um, and then what my loading code does, like instead of just kind of processing each of these images in like GIMP or something and then exporting each tiny one, I was like, dude, it'll just be easier if I load this stuff programmatically, you know? Um, so I just kind of, figured out the values for each of these pixels, like, left corner to top right corner. And like for all the sprites I want to use, I just kind of like have those values saved in my loader, and then we just use those. So yeah, like we have this function that's just load link sprites. And what we do is we have this whole file loaded in memory somewhere, and then for we store kind of like pointers to each of these locations, and we call that a tile. So yeah, like a tile, it doesn't have its own memory. It's all just kind of pointing to this single base BMP area in memory. So yeah, like his front tiles, it's like these are the X and Y coordinates and the width and height. And then yeah, it's just the same thing for all this stuff, dude. So yeah, like use sword left, like this is his pickup. And then like, yeah, there's different sprites based on like the point in the animation it's at. So like this boomerang, it like has like 8 sprites because that thing is just like rotating. Yeah, and like bomb dust, like it'll be like, so like we have 3 frames for that. And we just do that same recipe for like all this stuff. Yeah, so we have like the link sprites and item sprites, NPC, like overworld tile set, like all this stuff. So yeah, we just load all the sprites. So we have all their structs set up, and then that we just throw that into the giant game state struct. Yeah, so we're just like setting some properties on the world here. This is where I set up the spawn room. So like I have a certain map or like tile room, and that's this like main room. So I just kind of set up like, okay, this is the main room, and then like I want these, Octoroks over here, and then I want the Moblins over there. Yeah, we have like, so each of these rooms, like we have to, by going left and right here, we have to kind of like connect the rooms together somehow. So I just kind of have these like connectors so that like when you run into the side of the room, then you like trigger this connector, and then it'll say like, okay, am I connected to anything on the left? And it'll be like, yeah, I'm connected to the spawn room. So yeah, and then it'll spawn you just kind of enough off the screen to where you're not gonna like accidentally, collide backwards and then be like flickering back and forth. So yeah, it's like pretty smooth and quick transition between each of these things. And then yeah, so like we have room connectors like this, and then also each room could have a door. So like if you're not up, down, left, and right, you might have a tile where the tile is specified as a door. So here it's like this tile here, it's like, oh shit, you hit a door. And then I'll go, okay, where does the door link to? And it goes to this cave room. And then when you hit down here, it's like, okay, what room is the down area linked to? It's the spawn room. So yeah, here, let me go to a place that's safe because I don't want to get hurt. So yeah, we set up all the connectors for everything. We have bush room. That's the room with all the bushes. It's bush room. Yeah, the cave room. Yeah, so we're just setting up like the sword that you could pick up, the fire. All pretty self-explanatory. This is the dungeon rooms. Alright, so this is all the initialization step. So then we say, okay, memory initialized, true. Here, let me see how long this recording's been going too. Alright, 25 minutes. So then we say memory is initialized, yes. So that's the whole initialization block, and now it's time to get into like the real shit. This is we're updating stuff now. So yeah, we update all the entities. That's the first thing that we do. So yeah, this update entity function. We have an update function for each of these guys. Yeah, like I suppose I thought about doing like a function pointer or something inside the entity struct, but I was like, I don't know if that's really worth it. Like it seemed easier for me to just kind of do this giant if block, because then I could pass in whatever like function arguments I want, and I could be like particular about what actually goes in here. So yeah, if you like the update Octorock, this is just kind of all the like AI logic. So yeah, you can see like new algo, go forward until hit a wall, then turn in a random direction. So that's what this does, I guess. Yeah, and then bro could fire some projectiles, and then if you fire one, then the projectile is its own entity, so it'll allocate a new entity in the room, and now the projectile is like free to go. And then when his health gets to 0, then he's no longer active, and then that frees up the entity slot. So if someone wanted to like spawn a new projectile or something like that, they can do that. Okay, so over to update Moblin. All this stuff is pretty self-explanatory. Yeah, so this is just kind of it goes in a straight line in whatever direction it was initialized to, and then once it's off screen, then it dies. Yeah, update sword. This is just kind of, so this isn't like the sword that you hold on to. This is the sword that like lives on the ground and you have to pick it up. So yeah, here we just have this like is colliding thing. And then like, so if the player walks into the sword, then it changes up the game state. Whoa! It changes up the game state. So yeah, it says like player picking up thing now, so that triggers the like, oh, it triggers that animation. And then it sets itself as the entity that's being picked up. So then when you do the pickup animation, it kind of knows what entity to like raise above Link's hands, and then to like deactivate when the animation's done. So yeah, bomb. That just kind of, when you place a bomb down, then that spawns a bunch of bomb dusts. And then if you're an enemy and you like run into the bomb dust, then you're gonna take some damage. Yeah, so that's there's something interesting going on with the push block, but I guess I could just talk about this now. So yeah, the push block, you could see how like when I was pushing it, if I go back over there, when I was pushing it around, it kind of has this little animation where it will just kind of like go over to this slot over here, right? And to implement that, I have this like tween system. So yeah, tween is like when you have 2 points and then you want your thing to like smoothly slide between the 2 points like over a period of time. And it's a nice like abstraction, so I don't have to have this thing that's like, like some code where you have your block and then like it changes position over time, like just specific to the block. I felt like the tween thing was a good system to add in to like reuse in the future. So yeah, entity tweens. This is just like you have your entity it's attached to, and then we have a vec2, which is the path that you go along, and then like the length of the path, and then how deep into so the length. The length is not how long the vector is. The length is like how many frames do you want this tween to take place over. And then the current frame is just like, okay, how far into the tween am I? Yeah, and then we have a tween queue, which this contains, like 32 tweens. So if I had, like a push block, but then I also had some kind of thing flying around the room or something like that, we could just kind of go through each of these tweens that we have going on and just like update all of them for a single frame. So if you had multiple push blocks or something like that, you could, have all of them do their thing without like stepping on each other. Yeah, so this update entity thing I think is pretty self-explanatory. So moving on back to, this is the main game code, the main update code. We do some player input processing. So this just kind of sets the player speed and direction, and will, trigger certain stuff like player using bomb if you press the bomb button. Yeah, some other logic stuff down here. Player using sword. So yeah, when you use the sword, then you have like a sword animation. So you kind of want to know how many frames into the sword hit you are, to get the animation right, and then also have like know where your sword hitbox is and stuff like that. Similar type of thing for the walking animation. We're just like doing a two-step thing. Yeah, this is the player pickup thing. So this uses like a start ny. Like I must have written this before I implemented the tween system. So this I'd refactor in the future to use tweens. This is where we actually where we update all the tweens. So yeah, we just have a for loop, and it just does some increments for each of the entities in the tween queue. Yeah, here's some stuff for updating the boomerang. So yeah, like the boomerang, if I throw it, I'm allowed to move when it's on its way back. So yeah, it goes out and then it kind of has to like find its way back to the player once I'm moving around. So yeah, it goes back there. Boom. Pick up this key, throw another boomerang. Why not? So yeah, all the boomerang logic is in here. It's all just kind of game logic stuff, so not too interesting to talk about. Let's see what else we got on here. Yeah, the dungeon doors. This was a bit of an interesting thing, because what I thought I would do with the doors is just kind of make it a part of the default tile map. But because of the way all these tiles are set up, like I could show you what the dungeon tile set is. I just did not feel like breaking this thing up into a bunch of its own tiles, because I'm sorry, I just wasn't gonna do all that. I wasn't gonna load this thing and then draw this room. So I just wanted to take this whole room and then just kind of splat it onto the screen. And then yeah, we have these like colored slots here for doors. So this setup didn't really integrate well with my existing tile system. So I just kind of decided that these dungeons are going to be like special cases, and then I could always change the stuff in the future if it becomes a headache. So what happens is like, normally like if I go out here, this whole overworld, all this stuff is just stored as like a tile map. But here, just this walkable area here, this is the tile map for this room. And then this thing, this whole border, this is just drawn as like a sprite around it. And then these doors here, these are just kind of drawn on top based on the dungeon state. So if I go over to, not this, but let's see, where my dungeon's at. Your dungeon room. No, that's some rendering stuff. Is it in here? Nope. Bro, where are my dungeons at? Alright, here we go. Yeah, so each tile room that I was talking about, like it has its entities, but also it has this like dungeon door stuff. And it also has a room type. So if you're an overworld room, then we will just like draw the whole thing as a tile map. And then if you're a dungeon, then we'll do this like dungeon specific drawing routine. And then also we have all these dungeon doors. So we have a door area. That's kind of how like it knows to let you like walk around and collide with the door. And then we have this door state. So it could be like a wall. So like these guys on the sides, these are just walls. And then this guy, this is a closed door. And then if I use a key on it, then now it's an open door. So yeah, it was like a locked door. And then this is a shut door. And then if I like kill this guy, then it will like, you know, unshut the door. So here, let me get rid of this guy. Alright, come on now. Just give me a second, guys. I didn't even pick up the frickin'... This guy not dying? Alright, must be some kind of bug, dude. Anyway. So, yeah, that gives you an idea of how the dungeon doors work. So the doors are kind of treated not as tiles. They're kind of treated as their own thing just because that was, like, it felt more pragmatic to program because I didn't want to spend a bunch of time, you know, tiling everything up just so it fits this, like, system. So, yeah, back to this. So, yeah, this just kind of handles the dungeon door logic. So this is like, okay, we check like does the player have a key in their inventory, and if the door is locked, then we'll, you know, open it up and then subtract something from your key inventory. Here, this is all the collisions. So we just kind of check, yeah, if you're like walking into doors or like, you know, hitting the edge of the map, then that will like take you to the other rooms that it's connected to. Yeah, otherwise we just handle like regular player movement, stuff like that. This is like for the player sword update, so it will like, we have the sword point, and this is kind of like the hitbox. So if an enemy is running into this one point on your sword, then it will take damage. Yeah, dungeon room completion check. We have an invincibility timer. So yeah, just like basic timers. A lot of these concepts I brought over from doing some work on Godot. Yeah, I did like a game jam on Godot, and I was using a lot of these concepts like, you know, timers and like area 2D and stuff like that. So I was just like, you know, these are like good abstractions, so I'm just gonna kind of bring them into this. So yeah, we have like basic timers. Yeah, when player is using sword, we're gonna like check if the hitbox is hitting anything. Yeah, so there's like certain things, just to point out, that like I totally could refactor this into a more generic system, like, you know, so I think this is something that would make sense as like the collision system, and then like recheck if any of these points are colliding with anything. But just doesn't seem like that pressing of a thing to abstract, and then like once you abstract it, then you're kind of locked into that, and it makes it a lot harder to work with. So I just figured I'm just gonna keep it how it is right now. Yeah, and then we update some timers at the end, and that's most of the game update loop. So next over here is the rendering. So yeah, let me see if there's anything else interesting. Yeah, like, so this is how I draw the overworld stuff. Like, I don't have like a tile map editor or anything like that. I just kind of, you know, have these strings that I put in here. And then I'm like, oh yeah, if you put like a B, then the B is the bottom middle wall. And then if you do an underscore, then it's the floor. Yeah, so I just kind of have this like Legend. You is Bush. You are Bush. Yeah, so that's how I draw tile maps. And then yeah, most of the stuff, like we have random. This is just like a big thing when you want to do random movements. This is all some basic math stuff. Yeah, all this stuff. I think I covered everything. Yeah, this is a bunch of stuff for tile map functions. Yeah, loading dungeon room, load overworld room. This is kind of like, this loads the tile maps I was just showing you, the like tile map strings. So it'll convert all these strings into like just arrays of like tile IDs. Yeah, it's like nice to kind of separate the game structs from like tooling. So I like to, you have your kind of little optimized ways of doing things that might change over time. So like this whole string thing, like I'm not going to be using this for a long time. Like eventually I'd like to have a little map editor that I could use, and I don't want to have to store things as chars. So like this stuff will go away, but these enums are going to stick around. Yeah, so these are all just like helper functions for getting and setting tiles and stuff like that. So I think it's a good point to get into the rendering now. So yeah, this is all a software renderer, so it's not using OpenGL. It just kind of draws everything onto this like small NES sized buffer. Yeah, and then it will just display it onto like a Win32 screen buffer, so you can see it like that. Yeah, so like I just kind of draw room tiles based on what room you're in. So like the overworld room, it just is kind of like a for loop of drawing all these tiles, and it'll draw the BMP associated with it. But the dungeon room, you can see, is a little bit different. So it will draw the tiles in the middle, but then after that it draws this whole like room border. That's what I was talking about with this image over here. It'll draw that. And then it will draw all the doors, and then it will draw like different sprites based on the door state. So if the door is open, then it will draw this guy, and then if it's a wall, it will draw this guy, and then if it's exploded, then it will draw this. Yeah. So yeah, we have draw dungeon room. What else we got? So yeah, this is just drawing the player. Yeah, this is like all the animation stuff. So yeah, like it's all pretty specific to what the sprite is doing and stuff like that. Like it's not like Godot where you're just kind of like using all these animation system and like sprite changing system and stuff like that. Like it's all just kind of like, oh, what's the game state? Okay, I'm gonna draw this sprite. And like if you're just one person working on this engine, it's like really easy to just kind of hack all this stuff together. Yeah, like it's very simple and straightforward. So like it looks like a lot of code, but it's actually pretty easy to manage. It becomes a lot more difficult to manage once things get very like systematized, because then it's like, oh, how do I like reason about this system that like I haven't used in a while or something like that. So yeah, I find it to be pretty pragmatic. Yeah, I draw some debug stuff. Let's see what else we got here. Yeah, this is like for drawing the HUD. So we'll draw like some. Yeah, this is where we draw like the coordinates of the player. So yeah, you can see up here we have like the coordinates on the side, and then we have like the hearts. And then it was dangerous to go low on 420. I don't know. I like put this here when I was working on the drawing the text, and then I just had to delete it. Yeah, and then the draw entity thing is nice. We could just kind of draw all of our entities in a for loop. So yeah, if I pull up the function, it's all, we have draw fire, draw moblin, and this just handles like the flicker and the fire animation or something like that. Yeah, most of this stuff is just like, well, okay, just draw the sprite. But some of the stuff, like, it handles animation and stuff like that too, based on the state of the entity. Yeah, draw boomerang, draw cave text. So yeah, this is where we have the scrolling text. So yeah, this is a bit more like sophisticated, I guess. It's like we have an index that the cave text is drawn, and then we'll just draw the string like up to that index. So when I walk in there, you could see it scrolls like that. So it'll say like, okay, go up to the index, when it's on frame 15, it will draw the R and then not anything else. And then like I have a if-else statement so that it could span over multiple lines. So that's something that like, I mean, you could make it into a more sophisticated like abstract system, but like we only do text scrolling like this for these cave things anyway. So it's just kind of, this is all you really need, Yeah, dungeon room layer 2. This is the second layer, I guess, on top of. So yeah, this is where we draw the doors and stuff on top of the dungeon. Yeah, and then this is where we draw the health. So yeah, and then we just update the frame counter, and then you can see like when we draw a BMP tile, like this all gets drawn into this game off-screen buffer. And yeah, if I go into that, it's just like memory width height bytes per pixel. And yeah, so then you send that, like that's basically the whole game update loop. Yeah, lots of just like, straightforward C code. There's no like fancy C++ or anything like that. And then yeah, if we go back to the platform code, like I was talking about, like, so that was the game update and render. So once this thing is done, it will output the updated frame into this video buffer, and then this gets, blitted onto the Win32 window using the stretch DI bits thing. And then yeah, that's basically it. So that pretty much covers everything. I don't know how much more work I'm gonna do on this engine. I'm kind of interested in getting into writing some more 3D stuff. So I'm probably just gonna take what I learned from this and get into writing 3D. But yeah, I just kind of wanted to document this thing because I spent a bit of time working on it, and I thought it was cool. So yeah, thanks for watching.